So as a background, the previous extractive related work generation extracted salient sentences from the cited papers and concatenated them all together as an output of the related work section. So there's no transition sentences considered at all. While previous abstractive related work generation works, they worked on generating individual citation texts before LLM came out. So as a result, both extractive prior extractive and abstractive related work generation approaches, they all ignore the relationship among the cited texts, cited papers in the related work section. So in this work, we study how to generate the related work section with a coherent story. We use stepwise generation by first generate these features using the GPT 3.5 turbo model, and then gather all the features we generated and use the GPT-4 model to generate the full related work section. Due to the challenging nature of related work generation evaluation, no model nor ordinary person can really evaluate related work section. Therefore, we asked 27 experts who are either the authors of the related work sections or very familiar with the target paper for the human evaluation. We ablated various features and then scored human evaluation metrics in 5-point Likert scales. So we got a whole bunch of interesting results. As table 4 shows, we found most of the features we propose useful. They are the main idea of the target related work section provided by the user, human user, and also the target paper's title, abstract, introduction, and conclusion section. And the third is the citation intent or relationships between each cited papers, and also the cited papers abstract. And finally, sometimes cited text plans are also very useful. More interestingly, we also used the COLA joint related work tagger that we introduced previously to predict the citation types of each generated citation for writing style analysis. So as you can see in the red boxes, both related work section contain much more reference style citations than our generated related work sections. This indicates our generated related work sections are more like the concatenation of the summary of each cited paper, while the human written related work sections tend to use coherent story to connect short citation spans together. More interestingly, we found that there's a strong correlation between the human preference and the Rouge L scores, and also between the Rouge scores and the proportion of the reference type citations shown here. By the way, so the Rouge score, measures the similarity between the output related work section and the gold related work sections. So overall, this observation implies that the readers prefer more high-level abstract citations with transition sentences between them to provide a coherent story. So finally, we summarize the challenges we identified in related work generation. First, we found that the factual errors are something that human readers are very sensitive to. And we didn't talk about this in detail, but please refer to my chapter 8 dissertation for more details. The next challenge is citation ordering and organization. So this is mostly underlooked by most of the prior works. In our work, we found that the human readers do not like simple concatenation of the cited paper summaries. And it's important to emphasize the right cited papers, not the random ones. And as a future work, we suggest automatic citation ordering and grouping. The third challenge is the transition sentences and the writing style. So previous extractive related work generation and citation text generation did not really consider this at all. So we suggest distinction between the reference type and the dominant type citations. Our final challenge is retrieval augmented related work generation. So far, all existing related work generation works all assume the list of cited papers is available already as an input during this task, which is clearly unrealistic. So as a future work, we suggest start with a partial list of works that should definitely be cited, and then iteratively, and then alongside a set of also alongside a set of candidate works that might be related, and then we iteratively use retrieval augment generation to select a candidate paper and then generate its transition and citation sentences.